In this lecture, we will discuss how to connect a DC motor to the arduino board. DC motor, it converts electrical energy in the form of direct current into the mechanical energy in the form of rotational motion of our motor shaft. In order to have complete control over the DC motor, we have to control its speed as well as its direction. This can be achieved by combining the two techniques. One is PWM to control the speed, and another one is H-bridge circuit to control the rotation direction. The speed of a DC motor can be controlled by varying its input voltage. To control this input voltage, we are using a technique which is called as PWM, that is pulse width modulation. PWM is a technique where the average value of the input voltage is adjusted by sending a series of on and off pulses. Similarly, to control the rotation and direction of the DC motor, we are changing the polarity of its input voltage. This changing the polarity of the input voltage can be done by using a circuit which is called as H-bridge circuit. This H-bridge circuit can be comes in the form of a IC which is called as LM293D. This LM293D is called as a motor driver IC, and this is the pin diagram of L293D, that is motor driver IC configuration. It is a 16-pin dual channel IC, and it contains the H-bridge circuit capable of driving a pair of DC motors or one stepper motor. That means it can individually drive up two motors which can be used for the applications which contains two-wheel robot platforms. If we observe, this L293D contains two VCC pins. VCC1 is used to drive the internal logic circuitry, which should be of plus 5 volts. VCC2 is used for the H-bridge to get the power to drive the motors, and it can be 4.5 volts to 36 volts. And these two pins are synced by using a common ground. And L293D motor driver output channels, that is out 1, out 2, out 3 and out 4, are used to connect the motors A and B. And this IN1, IN2, IN3, IN4 are used as a control pins, direction control pins. And the direction of the control pins can be change its direction by using this particular channel. Here IN1 and IN2 can be connected one motor, IN3 and IN4 can be connected to another motor. And this IN1, IN2 pins control the spinning direction of the motor. Similarly, this IN3 and IN4 can also control the spinning direction of another motor. If these two IN1, IN2 values are 0, 0, then the motor will be goes to the off state. Similarly, IN1, IN2 or 1 and 0 are high and low, then the motor will be rotated in forward direction. Similarly, IN1, IN2 are low and high, then the motor is rotated in backward direction. If these two pins are high, then the motor will be goes to the off state. The same table can be applied for this IN3 and IN4. So the speed of the motor is controlled by using this enable A and enable. This can be connected to one motor and this can be connected to the another motor. These ENA and ENB are used to turn off and turn off the speed of the motors of A and B. Pulling these pins high will make the motor to spin. While pulling it low will make the motor to stop. And you should remember that both these ENA and ENB, that is enable pins, are connected to the PWM pins of our Arduino board. This is the interfacing diagram, how the two motors are connected to this Arduino through this driver motor IC. And here we are using 6 pins, whereas the first 3 pins are used to drive one motor and the next 3 pins are used to drive the another motor. Enable A, IN1, IN2 are connected to the digital pins of 9, 8, 7, which are used to control one motor. Similarly, the IN3, IN4, enable B are connected to the 543, which are used to control the another motor. But we should be careful that this enable A and enable B must be connected to the PWM pins of our Arduino. And this out1, out2 and out3 and out4 are connected to this motors. And this is the program to run the motor in the specified directions as well as to control the speed of the motor by using our PWM pins. And here, as already we know that this 789 or 987 are used for motor A and 354 are used for motor B. Enable A, enable B are connected to the 9 and 3. 8 and 7 disturbance are connected to the IN1 control pins of our motor and 5 and 4 are connected to the 3 and 4 of our L293 driver IC. And in the setup function, we should declare all these pins as output pins by using pin mode statements. And initially, we are turning off the two motors just by passing all the values as low as per our table. So if we pass the IN1 and IN2 are the low values, then the motor will be goes to the off state. So to initialize or to turn off the motor, initially we are passing the low values to the IN1, IN2, IN3, IN4 by using the digital write statements. And in the loop, we are calling two functions. One is to control the direction and another one is to control the speed. Now, the direction control function will follows like this. So to control the direction, we are enabling the ENA and ENB of the two motors just by passing the high values, that is 255, by using this analog write function. And to turn on the motor, we are passing high and low values to this IN1 and IN2 pins. High and low values to turn the motor in forward direction. Similarly, the same can be applied to the another motor. Next, to change the motor direction, we are reversing the values of this IN1, IN2 from high to low and low to high. The same can be applied to the second motor also. And to turn up the motor, again, all the pins can be applied to the low values. And to control the speed by using the enable pins, we are using this particular function. So first we are turning the motors and we are moving the motors in the forward direction by applying low and high values. And to control the speed, we are passing the different values for these enable pins by using analog write. To increase the speed of the motor, we are passing the enable A values from 0 to 255. The same thing can be applied to the another motor. And to decrement the speed of the motor, we are passing the values from the maximum speed to the 0. That is in the reverse direction, which decrements the speed of our motor. After that, we are turning off the motor just by applying all the low values to this IN1, IN2, IN3 and IN4. So by using this direction control function and speed control function, we can observe the behavior of the motor in all the directions, as well as we can observe the behavior of the motor in the speed. Thanks for listening to class.